So good evening, everybody. Tonight I will present to you a hitchhiker's guide to chemicals in the environment. You will hear how chemicals get into the environment, what they do there, and why this should be interesting to you all. I will also talk to you about how computer models can help us to understand all that stuff. So, first, chemicals in the environment on a large scale are basically mostly harmless. Unless we get closer to a small little planet which is in the very outside of the spiral arm of our galaxy, planet Earth. Here, 100,000 years ago, still quite idyllic, until a species came up that claimed to be the third most intelligent species on Earth, the human being. At the beginning, he was still quite harmless, thinking basically of getting food and maybe having sex. This doesn't interest us all at all. Then it became more problematic when he started to develop technology. But it became really detrimental for Earth when he started to think about deeper things, about the very nature of nature. Because this accelerated his train forward in the development towards the development of alchemy, where he pretended to modify molecules, chemicals, and determine the fate of Earth. So let's go quicker into the present. Today, chemistry, what has developed from alchemy, is basically a toy for children. So that no wonder that at some point in the last century, this third most intelligent species on Earth thought it wouldn't be a nice idea to have a chemical that kills everything that bothered him at this time. And the answer was DDT. To say it in simple terms, dichloro-diphenyl dichloroethane. But you don't have to remember that. So this chemical was so cool, it killed everything that bothered the human being. Starting from all these little insects and animals that were eating the crops of a human being. It was even killing all the parasites that the third most intelligent species on Earth had all over its hairy body. It was included actually in wallpapers of little babies' rooms. The babies didn't know at this time that eventually some of them would die from this treatment. Nevertheless, DDT had a glorious time. So, you agree maybe that for an outsider this is kind of puzzling, right? But what are the risks today? There are about 100,000 chemicals on the market. 22 of them are regulated globally because there's concern about their risks. And there are several 100 chemicals with possible negative effects, like reducing your offspring, affecting your growth, affecting your intelligence, or which might simply kill you. So, to illustrate a little bit what is about this several hundred chemicals that are all around us, I brought some items with me to illustrate this. This here is a simple frying pan. Don't tell my wife that I took this from her kitchen, please. There are perfluorinated compounds that make that the food doesn't stick if you cook it. Cool idea, basically. Also, the same chemicals are here in this food packaging, which makes that the Big Burger or the Big Mac or whatever doesn't soak into your food packaging. Electronic devices are full of flame retardants, mostly brominated, that make that in the case of fire, your electronic device wouldn't burn so quickly. Personal care products, full of siloxanes as a carrier material. Also UV filters. Yeah, hit my fan club. And you might know this here is a sealant. This is to make, you put into your walls so that the rain stays out, the heat, the warmth stays in. Earlier in the do-it-yourself shop, still with PCBs of polychlorinated biphenyls. Today, not anymore, but quite ugly. So this seems a lot of bad news. Don't worry. You don't have to worry as long as you are an organic farmer producing all your own food. If you rely on more traditional forms of telecommunications. If you don't care about personal hygiene. Or if you simply happen to be born in a parallel universe where the human being came only to be the fourth most intelligent species on Earth. Is anyone in the room who belongs to one of those groups? Yes? Yes? Great. You can leave the room now. It's not interesting for you anymore. All the rest, please pay attention. You should know your chemicals because they are around you and you might not even know it. So chemicals are not so much different than humans. They like diversion. They like to be in the water. Others like to be in the air. And even others prefer underground. Most chemicals switch between all those three elements. So to understand this on a global scale, it can become a little bit complex, and that's why we work on environmental fate modeling, computer models that try to explain the movement of these chemicals. And to do computer fate modeling, chemical fate modeling, you need first some highly advanced computing power. Here you see a picture of some colleagues of mine. You fill up these computers with highly sophisticated equations. Don't worry, I won't bother you with that today. Instead, I want to invite you on a virtual journey of a persistent chemical as it is hitchhiking all around the world and how our computer models would describe that. So, the chemical I want to present to you is Paul Christoph Blocker. As you might infer from the name, he's Swiss. He belongs to the group of PCBs, and he was originally intended to form part of a ceiling in a government building in Bern, but then everything got different. PCBs got forbidden in Switzerland, and he was forgotten in some barrel in his manufacturing site. So it seemed quite quiet for Paul Christoph, but then something unexpected happened. 1986, Switzerland. A heavy chemical accident in Schweizer Halle releases a bunch of chemicals into the River Rhine and others into the air. Also in the air goes Paul Christoph, our chemical. And he travels all over Europe. And he enjoys it quite a lot because the view is really nice there, up there in the atmosphere. But then, what Paul Christoph didn't know, there was a lot of other chemicals up there, radicals, OH radicals, about 500 million and 1 liter of volume. And those were quite aggressively attacking him all the time. So fortunately, Paul Christoph made his way to his first intermediate stop. He got 5,000 kilometers and vectored through the air. He needed 2 weeks for that and still survived with a probability of 99%. There he made friends with an atmospheric particle. And what happened then? He dropped out to the nice chilly soil of northern Siberia, the permafrost. It's quite chilly there, 20 degrees minus, so he could survive for 15 years and that's still a probability of 84%. Then with climate change, soils warmed up again. Paul Christoph got volatilized back to the air and drifted towards north and got precipitated in a massive rain event. I have to be honest, it was snow actually, but I couldn't find a sound effect for snow. So, what happened then? Paul Christoph traveled further through the ocean now, dissolved in the ocean water. About 12 years of travel time, and it's still with a probability of survival of 57%. So, what has happened there? There was Paul Christoph floating happily in the water when he made a new friend. It was a phytoplankton coming along, and it was a quite fun guy. But some friends are false friends. It was a mistake, because along came a fish and ate the phytoplankton, and with him Paul Christoph. But how life goes, there comes another fish, and eats the first fish, together with Paul Christoph. And you guess what happened? Comes an even bigger fish, and eats all the fish below. So that's a trophic chain, basically. The story could end here. It doesn't. It has a good ending for Paul Christoph, because the Arctic Fishery Council decided this year that the exports to Switzerland of fish products should be increased. So in the end, Paul Christoph came back home. So thanks for all the fish and enjoy your meal.